Today, it's great to chat with Andrew Huberman on the podcast. Andrew is Associate Professor of Neurobiology and of Ophthalmology at Stanford. His lab is focused on brain function, development, and repair, with emphasis on regeneration to prevent and cure blindness. They also study the neural circuits that control visual fear and are developing tools to remap them and to treat anxiety disorders. Additionally, Huberman is host of the popular podcast called Huberman Lab. Andrew, it's so great to chat with you today.
Great to be here. I've been looking forward to this. Thank you for having me on.
Thanks. I've been really looking forward to this as well. Congrats on the awesome success of your podcast. What compelled you to do a podcast?
The short answer is I have the great Lex Fridman to blame for that one. Lex Fridman, as some of your listeners may know, is a researcher at MIT, computer scientist, physics, a guy who has a podcast where he interviews scientists, and now he's branched out to talk to people in cryptocurrency and martial arts, all his interests. And I was a guest on there, and Lex and I got to be friends, and we had a little discussion. This was end of 2020. I'd been teaching neuroscience on Instagram for a couple years. I started that in 2019, and I was a guest on various podcasts. And then after we finished recording, Lex said, have you ever thought about starting a podcast? I said, no, absolutely not. But then, he impressed upon me that, that there's a lot of interest in science learning. And I thought, I love the field of neuroscience so much. And I love a lot work that's done by other labs, not just mine, of course. And there's so much out there that I feel people could know about and should know about and could benefit from learning, that I thought, I'm going to do a podcast that's more or less the equivalent of a university lecture for the first 20 minutes, kind of introduce a topic, a little bit of mechanism, and then talk about some tools that stem from that mechanism. And it's a different sort of podcast for a couple of reasons. One is that we don't jump from topic to topic. We do an entire month focused, for instance, on sleep and how to get better at sleeping, or neuroplasticity and how to get better at changing your brain and what the science has to say about that. And so in some ways, it's a little bit more like a university curriculum merged with a podcast. But that's the reason. And I've had a lot of fun doing it. I'm still learning. There's a learning curve, of course, for me. But thus far, it's been very gratifying. And we're always seeking to be better. And I realize as I'm saying this, Scott, that we've got to get you on as a guest at some point, because we are soon going to have guests. Cool. Right now, it's just been me blabbing at the microphone. But starting soon, I've got some colleagues from Stanford and elsewhere who are going to come on. So maybe we can turn the tables on you a little bit and have you on as a guest. That'd be a pleasure. I mean, no pressure or anything, but it'd be great if you would.
Well, I would love that. I humbly accept that invitation. Yeah, so I'd like to talk a little about your background a little bit. I'll go back a little bit. And can you kind of tell our audience what you got your degree in, your advanced degrees, and what maybe even your dissertation topic was about, and how that led to the work you're doing today?
Sure. I got interested in neuroscience when I was a sophomore in college. I was studying psychology, actually, and I took a course in abnormal psychology, and this was the early 90s, and the drug Prozac had just been released, essentially. The book Listening to Prozac had come out, and I was fascinated by some of the more biological aspects of abnormal psychology. I don't know if they still call it abnormal psychology, but, in an abnormal psychology class in the 90s, you'd hear about schizophrenia, depression, OCD, et cetera, which I guess, given the prevalence of those conditions, I guess now we should probably call normal psychology. And there's so many people challenged with it. So probably the course should be renamed now. But in any case, I started realizing that my interest was moving toward neurotransmitters and things of that sort, but I didn't know anything about it. So I took a class in what at that time was called biopsychology. The field of neuroscience did not exist. There was no named field of neuroscience, nor was there any neuroscience program or department in the world at that time. It's kind of interesting how young a field neuroscience is. There was neurobiology, neurophysiology, psychobiology, which is a wild name, biopsychology. But what happened was I started looking for courses. I started taking classes in physiology, in cell biology, and psychology. And in the end, I got my degree in a combination of biology and psychology. And I worked in a lab, did a senior thesis looking at thermal regulation of all things under conditions of MDMA exposure. So these are animals that we would give ecstasy, MDMA, and we looked at how they would change their perception of temperature. That was my senior thesis. We published that. I loved working in the lab. I found that working with my hands was something I really enjoyed. I never really liked working with animals much. I'm an animal lover. And also I didn't really enjoy it that much. But I did do that, and my lab still does that to some extent for the 25 plus years following. Then what happened was I went off and did my master's at UC Berkeley. It was intended to be a PhD, but it had a master's along the way. And I was studying the effects of two things. One was the effects of early androgen exposure, testosterone and its derivatives, on differentiation of the brain in humans. She was part of a study by a guy led by a guy named Mark Breedlove that explored how the digit ratios, the length of our fingers, actually correlates with two things that are interesting. One, how much testosterone we were exposed to in utero while we were still in our mother's womb, and how that impacts, believe it or not, sexual orientation in adulthood. It's a very robust literature that has now been replicated 6 times. We don't have time to delve into it, but I was fascinated by hormones and behavior. And I was also studying a system called the circadian timing system, how light orients our sense of time and when we sleep and when we are alert. Along the way, I took a class from the great Carla Schatz, who is the person who coined the phrase fire together, wire together. Carla is a absolutely world-class researcher in the field of brain development and plasticity. The phrase fire together, wire together is often ascribed to Donald Hebb, but that is incorrect. It was Carla who coined that phrase. Wow. Hebb said something else, which was unrelated, actually. But for some reason, it falls to Hebb, but it's Carla's. And I started hanging around people in her lab and learning how to do the sorts of experiments they were doing, which was looking at how electrical activity in the brain shapes the brain and how neuroplasticity occurs, how we can change our brains in response to experience. So I had the challenging but turned out to be fortunate circumstance of going to Carla and saying, hey, I really want to do what you do more than I want to do the stuff that I'm currently doing. And she said, well, I'm moving my lab to Harvard, but there's a lab up the road at Davis, UC Davis, that's working on some similar things. And there's a new PI there. I think you'd enjoy working with her. So much to the dismay of people that were close to me, I took my master's from Berkeley, did not take my PhD. I left by choice. I was doing fine in the program. I moved up to Davis and started working in a lab, working on these questions that I was really drawn to. And I ended up doing my PhD in the lab at Davis of a woman named Barbara Chapman. And my thesis was on the role of neural activity and molecular guidance cues, chemicals that shape the developing brain. And I have to say, Davis was a great place. I loved it. It's still a great place. I think just as a little bit of a message to any of the listeners who might be pursuing degrees in science, I've always focused on particular scientific questions and asked where could I be most productive around those questions for the next 5 or 6 years. Walking away from Berkeley was hard. I loved Berkeley. Davis was this little cow town, I thought, on the way to Tahoe. It didn't have the prestige that Berkeley had, and yet my time at Davis was one of the most productive phases of my career. Barbara and I published a lot of papers together. We had a lot of fun doing it. And then when I finished, I did a postdoc at Stanford with the late Ben Barris. Ben worked on neuron glial interactions. And Ben is actually quite famous for not just his science, but he was a big advocate for women in science, because before he was Ben, he was Barbara. So he did the control experiment. He had the experience of being a woman in science and a man in science. And I absolutely loved working with Ben. We were very, very close. And I didn't work on anything related to what Ben worked on. he let me come to the lab and work on finding genetic markers for neurons in the eye that degenerate in blinding diseases. So I skipped to that. I had a ton of fun doing it. And, sadly, Ben passed away in 2017. But that was great fun. And then I was a assistant professor at UC San Diego, where I continued to work on neural regeneration and repair in the eye. And we started to work a bit on how internal states like stress, et cetera, impact behavior, in particular fear behavior. And then I was recruited back to Stanford, where I'm now an associate tenured professor of neurobiology and ophthalmology. And my lab works on neural repair and brain states such as fear, performance, et cetera. So that was a long answer, but the common thread through all of it is I'm absolutely obsessed with biology and neuroscience, and physiology and psychology. And I've basically let my interests guide my choices. I've never married myself to one particular line of work, and it served me well. It does help to have tenure if you're going to switch fields, but I've had great fun, and I've made the decision that my life as a scientist will be pursuing the thing that interests me most, and I will never ever allow myself to wish I was working on something else more. I'll always work on the thing that I love the very most, without negotiation.
I love that. I love your commitment to science, and also your love for the biological basis of human behavior. In some circles, that's just, even studying that is controversial. Like, even if you just say I study, it should be the most uncontroversial thing in the world to say that there's a biological basis to human behavior. Have you faced any sort of pushback by any of your colleagues or anyone?
Well, let's see. Stanford's been very supportive. When I started podcasting, I worried a little bit that, anytime an academic starts putting their neck out there more publicly, you always worry a little bit. But they've been very supportive of that. In terms of, like my podcast and some of the work I do in my lab now is so human oriented. It's about tools that humans can use. We have a human lab. We went from studying mice, and we still study mice because there's some questions you can only address in mice, to a lab that does virtual reality and studies fear in humans. We study sleep in humans we measure people's sleep while they're out there in the world. We're doing that right now. They're breathing while they're at home. We're measuring that. I think it's fair to say that some of my colleagues probably, and not just at Stanford, but in the scientific community at large, probably wondered, what is Huberman doing? He's been working on mice and ferrets and, this kind of thing. Was he doing working on humans? But there's one solution to that problem, which is to publish really good papers. And I'm quite happy with the fact that we've published some papers in humans now, and we've got more on the way. And the solution to any critique or potential critique is always going to be productivity. And I felt that it was just crucial to move to work on humans. And I suppose occasionally people will say, well, what about the psychology of this particular behavior, like stress, or what about spiritual aspects to this? And my response is always the same, which is I have a choice to look at things through any number of different lenses, but the lens I know how to look at things through is the lens of science and neuroscience and biology. So when I hold up a lens to something like depression or stress, I'm in no way, shape, or form saying that spirituality or that psychology or sociology don't play a role. I'm just saying I'm looking through this particular lens. And so I think something that the general public and the scientific community, frankly, ought to learn more or consider more seriously is that something can be highly accurate without being exhaustive, right? You can be absolutely right, but you're not right about every aspect of something. And so my goal and what I know how to do is look at particular problems, including human behavior and human brain states, through the lens of neuroscience. But I certainly don't claim that those are the only lens that we can look at things through. And it's fun to consider what a view of something like stress might look like through a different lens, but I'm just not trained to do that. So I also tend to stay in my lane as much as possible, although I define that lane pretty broadly as a biology. So no real pushback. one thing, and I'm sure you've experienced this too, Scott, as a trained academic, is that occasionally, or I should say often, people will say, what about the work of so-and-so? What do you think about the work of so-and-so? And they're usually asking about some online self-help person that is not, I might have a background in neuroscience, but they're not a professional neuroscientist. So I never comment on other people's work unless it's published in scientific papers, or I can comment on their ability as a communicator. But there are a lot of theories out there that probably are worthwhile, even though there's no peer-reviewed study to support it. But I can't comment on that because I can't see the data. So when people, I won't name names here, but you can fill in your favorite online guru. People will say, oh, that sounds a lot like the work I heard about of so-and-so. But if it's not something I can look at in a manuscript or a textbook, I can't really work with that. But I still think there's a lot of great stuff out there outside of biology. Of course there is.
Of course. Yeah. Thanks for that. Well, the topics you study are so relevant to the experience of humans. And I thought we could just go through some of the broadest topics of things that people, we can really apply for their own lives to make their lives easier. The first topic I'd like to bring up is the topic of emotions. It's a big topic. I thought an interesting way to kind of get into that topic is to ask you whether we can predict our emotions before they occur or before they kind of spiral out of control.
Yeah, great question. And certainly that's a challenging one. Emotions, as you know better than I, are difficult to define. The field of neuroscience doesn't even really know how to define emotions. People throw around things like fear and all this kind of thing. But in neuroscience, really, you can only measure behavior, especially in animal studies, because we don't know how. You can ask a mouse all day what it's feeling, but all you can do is measure its behavior. And people are not that good at understanding their own emotions or describing them. The language of emotions is both vast and non-specific, right? I mean, if I say I'm feeling mellow and happy, that's informative, but I have no idea whether or not that's the same as you're mellow and happy. I just don't know. So one of the things that we've done as a laboratory is to try and address this question through the lens of the autonomic nervous system. So the autonomic nervous system has all these fancy names associated with it, like sympathetic and parasympathetic. But the simplest way to think about it is that it's just a seesaw inside of all of us that adjusts our level of alertness or calmness. So when I say calmness, I mean parasympathetic nervous system, alertness, sympathetic, and it's kind of a push-pull between the two. And the autonomic nervous system is constantly adjusting our level of alertness and calmness. Alertness and calmness, for me, is a useful way to look at the question of emotions, because if you ask how alert or calm are you relative to the demands that are being placed on you, oftentimes you get an answer that relates to what we know as the valence of emotion, whether or not an emotion is good or bad, positive or negative. So for instance, if I'm sleepy and it's time to fall asleep, great, that's a great place to be. If I'm wide awake and I need to fall asleep, that's stressful. Okay. If I'm wide awake and I have a lot of work to do, that's generally a good place to be. But if I'm wide awake and I have a lot of work to do and I'm so alert that I'm panicking and I can't control my behavior, that's not a great place to be. Now, this is very coarse language to get at emotions, but it's the kind of thing that we can measure in the laboratory. And now, using various technology, we can even measure this sort of thing while people are out of the laboratory. So we take a very crude and yet a very tractable and measurable approach to looking at emotions. Now, we also get people's subjective reports of whether or not they feel good or bad, et cetera. But that's the lens that we look at this through. And it's not perfect. Lisa Feldman Barrett and other psychologists would say, I think quite correctly that emotion has all this context, right? Being devastatingly sad at the loss of a loved one is appropriate. Being devastatingly sad because you wake up and you can't attach that to any particular life event is called depression. So there's this very interesting issue as to whether or not our internal state, which includes alertness and calmness, matches our external pressures or environment. And That equation plus our kind of goals in life, short-term and long-term goals, generally, at least to my mind, spells out to whether or not you're happy or sad, right? So, or works out to whether or not you're anxious or mellow, or appropriately alert or appropriately sleepy. And so I don't want to, just shed a ton of parameters on this, but I would say the tool that emerges from this is that if people can start to afford a little bit of control over their internal state, what we've found is that then they can adjust their emotions in air quotes for those of you listening, they can adjust their emotions by simply changing their relationship between their internal world, what we call interoception, your perception of your internal state, relative to the external world. So for instance, if I am very alert and it's time to sleep, and I can actively calm myself by using particular approaches, which one can, and we could talk about, then I can suddenly go from being stressed to feeling great because I'm falling asleep and I'm sleepy, or I'm asleep, or I slept well. If one can adjust their level of alertness up in response to a demand, well, then we start to feel some control, some will over the world and in the world. And then people generally start to feel more, quote unquote, empowered, or as if they have more self-control. And so there are tools to do this. And so we look at emotions through the lens of this autonomic nervous system. And that brings us to the word states. I'm a big fan of the word states, and what I'm wishing for, maybe some of the audience will tell us, would be language that more accurately describes the human condition because it focuses on states. States of mind have a persistence. They can be short or long lasting. They have a valence. We can say they're great or they're terrible or just neutral. States are something that are, I think, more tractable than the word emotions. And states definitely are supported or have a foundation of alertness or calmness, is kind of tilting back and forth of a seesaw. So that's a long answer, but that's the way that we approach it. And I would say if anyone wants to have better control over their emotions, they should focus on learning to control this so-called autonomic nervous system, because that is going to be, at least by our data, more powerful than simply telling oneself, oh, I should be happy, or, oh, I should, focus on the good, not the bad. That's all powerful too, but we focus on the physiology.
Cool. No, that's very cool. Hey everyone, I'm excited to announce that the 8-week online Transcend course is back. This iteration of the course, which will run from September 5th to October 24th of this year, will use science to help you live a more fulfilling, meaningful, creative, and self-actualized life. There will be limited slots available, so save your spot as soon as possible. In addition to the regular class pricing, we're also offering limited slots for personal self-actualization coaching. Save your spot today by going to transcendcourse.com. That's transcendcourse.com. The Transcend course is just one of the offerings of the brand new Center for the Science of Human Potential. The Center for the Science of Human Potential's mission is to use science to help each person fulfill their highest potential and contribute to the good of society. Toward that goal, we offer classes, coaching, and consulting opportunities to help people apply the latest science to help themselves, their organizations, their schools, their families, and their communities to be more creative, loving, and full of transcendent possibilities. For more on the center, you can go to scienceofhumanpotential.com. Hey everyone, doing this podcast for y'all is one of my greatest privileges, but the costs of maintaining a professional production like this one really adds up. I'm grateful to today's sponsors who help fund the show, but if you'd prefer a completely ad-free experience, you can join us at patreon.com/psychpodcast. You'll get completely ad-free episodes, all while directly supporting the show for as little as $5 a month. That's patreon.com/psychpodcast. What do you think of William Fleason's model of trait density distributions? As all traits are distributions of states, that we can kind of change our traits by changing our pattern of states. I mean, it just seems to dovetail with what you're talking about a little bit.
Well, I have to confess, I'm not an expert in it. So I should certainly read up on it. So maybe afterwards you can send me down the road some great psychology references. As I mentioned, we look at things from a terribly narrow lens of physiology, but I'd love to learn more. But from the way you just described it, it sounds marvelous. I love that idea. And I love it because what I want to see is the field of neuroscience and psychology, which are now one and the same. I mean, that's one of the wonderful things about neuroscience in the last 10 years is the doors have just swung open to everybody from AI to psychology. But what I would like to see is some real progress in terms of concrete answers and first principles so that in 10 years, there's a common language for people to talk about emotions. But I love the idea that traits are assembled from an array of states. I think that's a marvelous idea, but then again, it's very much in line with the kinds of things my lab does. So I want to admit complete bias in my response.
I'll send you those papers.
Great.
Just while we're still on this topic of emotion, I'd love to hear more about the work you're doing with your lab to alter the neural circuits that control visual fear, and how to remap them and treat anxiety disorders.
Yeah. So the two main ways to adjust one's internal state are respiration, breathing, and the visual system. And we can talk about the visual system first. So first of all, the visual system and sight is the dominant way by which we navigate the world and survive and make sense of the world. For blind people, it will be hearing and touch. But for most people who are sighted, it's going to be vision. The two pieces of things in the front of your face called your eyes are actually parts of your nervous system, your central nervous system. Your retinas are part of your brain, and they are the only part of your brain outside the cranial vault, outside the skull. And they were put there for a reason, which is to adjust your level of alertness or sleepiness depending on time of day. That's why they were there. We know this because there are a set of neurons in there whose primary job is to set your level of sleepiness or alertness according to time of day. And the other neurons that are in there that see colors and motion and allow you to comprehend what the difference between a face and a car, those evolved later. So vision is by far the most powerful way in which our brain focuses, in which its emotional states shift around, et cetera. And a lot of this is happening subconsciously. So for instance, when we are stressed or simply more alert or excited, positively alert, our pupils get larger and they dilate. Our eyes actually widen. This is a non-trivial thing, but our eyelids actually open a bit more. When we're sleepy, our eyes start to shut. That's sort of a duh. But a lot of people don't know the reason for that is that the circuitry in our brainstem that controls our alertness, things like locus coeruleus, reticular activating system, all those fancy names, they connect very directly to the eyes. And when we are excited, we actually narrow, we contract our field of view. And in addition to that, because we contract our field of view, we get a more kind of soda straw or tunnel view of the world. We also start to analyze time differently. And the simplest way to explain this is that if you're ever in a rush or you're stressed or you're excitedly waiting for something, it will seem as if the outside world is moving much more slowly. The person in line in front of you at the grocery store while you've got your mask on and you're having a hard time breathing and they're returning something, you're like, oh my God, it's going to seem like they're moving very slowly. They're not moving slowly, you're just slicing time more finely. This is also why people who get into accidents or experience trauma will talk about things happening in slow motion. The opposite is true. When we are relaxed, our eyes start to close, our pupils constrict. They constrict for other reasons too, but they sort of constrict. And things outside us will seem like they're moving very fast. If you're ever sleepy and you wake up and you've had a rough week and you look at your email and there's all this stuff coming at you, you're like, oh my goodness, there's all this stuff. It seems like the world is moving fast and you're not caught up. You're not caught up. It's just that you're sleepy. And so the world you're slicing time in broader time bins. So it turns out that the visual system also can impact our level of alertness, just like our level of alertness can impact our visual system. And so what my lab has been focusing on is how if people, for instance, just take a panoramic view of their environment. So this is not moving your head around or moving your eyes around, but let's say I'm looking at you on a screen right now because we're doing this by Skype. But if I were to dilate my gaze so that I still see you, Scott, but I also see the walls behind me and the ceiling and the floor, and now I see myself in the environment that I'm in, that disengages a circuit in the brainstem and actually leads to a more active calming of internal state. Conversely, if I deliberately bring my eyes to what's called a vergence point, where I bring my eyes together at a common site and I start to look at that particular place, that engages a circuit in the brainstem, leads to increases in alertness, and actually leads to increases in cognitive focus. So cognitive focus follows mental focus and, visual focus. And so to repeat that, cognitive focus follows visual focus, and visual dilation will also lead to kind of cognitive dilation. And so what we've been studying is how tightening or broadening our literal field of view using our eyes can allow people to calm themselves or increase their levels of alertness. And there's a third way in which the visual system can impact things like fear. Some people will recognize this as the main thrust behind EMDR, eye movement desensitization reprocessing. For years, people would ask me about EMDR. They'd say, what do you think of EMDR? And EMDR is where you move your eyes from side to side while recounting a trauma, typically to a trained trauma therapist. And to be honest, Scott, I thought this stuff was complete hooey. I was like, this is ridiculous. How can that possibly be? I'm a vision scientist. I work on stress. This doesn't make any sense. And then I ate my words, because starting in 2018, 2019 and 2020, there were 5 papers published in really good journals, including Nature, one of the apex science journals, showing that lateralized eye movements from side to side, so just sweeping one's eyes from side to side, not up or down, and yes, eyes have to be open, leads to a suppression in the activity of a brain center that many people might be familiar with called the amygdala, which is a threat detection center in the brain. And I thought, that is crazy, but the data were so solid, and the groups that were publishing this were not psychologists. They were neurobiologists studying eye movements. So there was really an absence of bias there. And it turns out that the reason that these lateralized eye movements suppress activity of the amygdala, at least the reason we think they do, is that when we are in forward ambulation, when we walk forward, cycle forward, anytime we're in self-generated movement, we are generating what's called self-generated optic flow. Things move past us. Now, unlike your phone, where if you take a picture on your phone and you move your phone, it's blurry. As you move through space and you move your head and your eyes, you don't experience the world as blurry. And that's because you are constantly generating what are called slip compensating eye movements. When you move your head from side to side, your eyes are moving so as to not generate blurry images. And moving your eyes from side to side, even if just you're sitting in a chair or something like that, simulates forward movement. And we believe that forward ambulation, and this could be cycling, biking, walking, running, etc., provided you're not looking at your phone or some little narrow box of visual space, suppresses the activity of the fear centers. And this is, we're assuming, is part of the primordial circuitry by which animals, including humans, advance towards things that were uncertain. And so it is the great insight of the late psychologist Francine Shapiro, who was, I believe, in Palo Alto, maybe had an affiliation to Stanford, I don't recall. She created EMDR while taking a walk in the woods. That's how the story goes anyway on Wikipedia, that she was walking in the woods, was recalling something troubling, and realized that she was much calmer about it than when she recalled the same thing just sitting in a chair. She exported the eye movement component to her clinic. And just to be clear, a number of people have said to me, well, EMDR has mixed results for treating trauma and reducing fear. And I've talked to my colleagues about this, my colleagues in psychiatry. It turns out that EMDR is most successful in dealing with very specific traumas, specific events that can be recalled in detail as someone does this. And I would encourage people, of course, to do this with a trained professional. This isn't the kind of thing that you do at home alone, although there is a place for these eye movements. But it's not so good at, for instance, at dealing with like an entire childhood or an entire divorce or all of 2020. It seems to map very well toward recall of a particular challenging incident while moving one's eyes in this way is essentially uncoupling the feeling of fear from the recall of the event. Now, the movement of the eyes from side to side can be used more conventionally outside the context of trauma if one is feeling kind of nervous about public speaking or feeling too much internal arousal for whatever reason. I don't see any reason why trying it couldn't hurt in that circumstance. But in terms of treating trauma, there's decent success. And there's a great book I'm going to look over because I have it to my right, which is Eye Movement Desensitization and Reprocessing Therapy. There are 3 editions of this now written, and this is one of only 3 approved, I would say APA, American Psychological Association approved behavioral therapies. I think it's exposure therapy, EMDR, and now there's one other sort of exposure type therapy that's been approved. So it has some merit. And again, this is just vision, right? This is using the visual system to adjust the internal level of stress. And in certain circumstances, that can be very beneficial.
I really want to try it right now. I want to just sign up with a new therapist and try it.
Yeah, a number of people have reported good results with it. Not everyone. There are going to be some things, just like hypnosis is another area. My colleague David Spiegel at Department of Psychiatry at Stanford is actively involved in work on hypnosis and how it changes default networks in the brain and dealing with it. Hypnosis has a very high, greater than chance success rate with many things, but some people will not benefit from it as much as others. I think that's been shown too. That's
the beauty of individual differences. Some people have greater susceptibility to hypnotizability. Openness to experience, personality trait predicts that. Yeah.
Actually, there's a fun little twist there relates to the visual system. So Spiegel developed something called the Spiegel eye roll test. I can do it on you right now, and people can try it. Don't do this if you're driving. So because of the relationship between the brainstem and the eyes and eye movements, there's a particular aspect of eye movements that predict on a 1 to 4 scale how hypnotizable somebody will be. Let me see if we can do this by Skype. So if you look up towards the ceiling, Scott, if you look up and now just slowly close your eyes while maintaining your gaze upward.
Okay.
Okay. Okay. And then stop. Yeah. Okay. Stop. So I would say maybe you're like a 2. So Spiegel.
What's it out of? On a scale.
So what you're looking for. Yeah. So on a scale of 1 to 4. So I would say you're mildly hypnotizable, but again, I'm not an expert in this. Spiegel taught me this. So, and he's the expert. It's actually called the Spiegel eye roll test. But what happens is, as you look up, it turns out upward directed gazes are associated with alertness.
Okay.
Who would have known? But it makes total sense. And downward gaze and closing of the eyelids are associated with sleepiness. Yeah. Exactly. And when you hear it, it's like, oh, this is so obvious. But this is, again, ancient circuitry. So this looking up while trying to close the eyes is something that Spiegel discovered it's a kind of contradiction of goals, right? Of looking up, but actually closing the eyes. It's hard to do, actually. The eyes tend to flutter. And depending on how much the eyes roll back and you see the whites of the eyes, it dictates whether or not you're a 1, a 2, or a 3, or a 4. Now, yours rolled back a little bit, not a ton. And this is all correlative, but what they found is that this predicts hypnotizability. So some people also find it very hard to close their eyelids while looking up. And a really good trained clinical hypnotist will have you look up and then close your eyes. Stage hypnosis is a completely different business, and I don't even want to talk about it because it's kind of a disgrace to clinical hypnosis. But anyway, I'm not a trained clinical hypnotist, but I do. If people want to sample with clinical hypnotism, by the way, there's a terrific free app that Spiegel and colleagues released called Reverie, Reveri. They have a 1-minute hypnosis, a 5-minute hypnosis for anxiety, sleep, etc. It's available on Apple and Android, and it's a free tool, but it has backing in numerous clinical and peer-reviewed published studies from Stanford. So I just want to, this isn't just some random app. This is developed by people who do this for a living, who are, board certified MDs and things of that sort.
Well, that is super cool. I think I used to be more susceptible to hypnotizability, and then I started to wise up. I become more cynical. I became more cynical of people's intentions.
I thought I so enjoy your Twitter feed because
Thank you.
Your Twitter feed makes me less cynical. It makes me more positive, less cynical. Well,
can you imagine just how innocent I was before? Because I still am a bit, I have a lot of positive faith in humanity. I really do. But I used to be very, very like susceptible to like people like gullible, to the extent of just gullible,
Well, I think that Jack Feldman, who's a wonderful colleague who works on the science of respiration, breathing from UCLA, he likes to say, and he's a New Yorker, and he likes to say, be skeptical, not cynical. And I think it's a wonderful phrase. I think that's a great stance for scientists. I think it's a great stance for anybody. You want to be skeptical, but I think cynicism is tricky. And I should say that Jack, just since we threw out his name, has really been a pioneer, has been decades ahead in terms of understanding how the other feature of our brain-body relationship, the respiration centers, can shape our states of mind. And so much of what we're doing now in our Human Lab on breathing and respiration to allow people to adjust their states and access sleep, et cetera, much of that is built on the fundamental discoveries of Jack Feldman. And he's done his work in mice. We're working in humans. But we talk all the time, and I just want to tip my hat to him. These physiologists like Jack, Francine Shapiro, and the EMDR stuff. Actually, that was clinical discovery first. But the more that scientists communicate across fields, the better life gets.
Yeah, for sure. And I really like that you're giving credit to these other individuals, there's other scientists. While I have you here, since you are a neuroscientist, I'd like to double click or zoom in on the amygdala, because I think it's a very misunderstood brain area. And, you mentioned you kind of, associated like with how a lot of people associate with it as the, kind of the fear response. But it's been my understanding that the more nuanced understanding of the amygdala shows that it really has to do with just emotional significance more generally. And I was wondering what your thoughts are on that more recent research.
Yeah, I think you nailed it. I think so. The amygdala, we think of this, fear center. It means almond. It's these two little almonds on the side of our brain that are there just to make our life difficult. And we used to be hunted by lions, and now we're stuck with this amygdala, and that's all wrong, right? It's right. First of all, it's a big structure. It's a whole cluster of structures. It's part of a network. It does not house fear. No one brain area houses anything except maybe our pituitary, which houses a lot of releasing hormones, or our circadian clock or something like that. But it's part of a network, a neural circuit, as we say, that is involved in vigilance and assignment of internal state to external cue. I think there is an opportunity here for a brief little neuroscience lesson, which is every neuron or brain area basically does any 1 to 3 things. It's either a sensory thing, it senses stuff inside us and outside us. It's controlled in generating movement, motor, or it's modulatory. It's trying to adjust when to move to what kind of thing, or when to be afraid of what. And our entire experience can basically be distilled down to 2 things: interoception, our perception of our internal real estate, and exteroception, our perception of everything outside the confines of our body. And the best way I can think of to conceptualize interoception, exteroception from a neuroscience perspective is that our experience of life from the time we're born until the time we die, even in sleep, is like imagine a glass barbell with one sphere at one end and another sphere at another, and they're connected by a handle. We'll call it the tether. One sphere represents interoception and the other represents exteroception. And of course, they're tethered. And we can split our attention between what we're feeling inside and outside. So we can do this right now. if somebody wants to close their eyes, or if they can't close their eyes, just try and focus as much of your attention on the sensation of your skin in contact with whatever surfaces it happens to be in. You do that for a second. You just made the globe or the sphere at the side of interoception a little bit bigger. And as you did that, the exteroception got a little bit smaller. Okay. Now, if you open your eyes and you focus your attention intensely on something outside of you, like a point on the wall across the room, chances are you can grow that sphere of exteroception and you will forget about your internal state just momentarily. Or maybe your focus on your internal state will shrink. So you can try that for a second. So just try and focus externally. Often this is best by focusing your eyes on a particular point. Okay. Now, typically we jump back and forth, interoception, exteroception, all the time, and they're connected by the tether. So what the amygdala does is the amygdala addresses what is my internal state, and in my environment, is there anything that's novel or in particular threatening or exciting? And if there is, it starts to increase the robustness of that tether. It starts to link what I'm feeling internally to the actions of something external. And that is generally a threat, but it could be something positive. So if you look at humans who lack an amygdala, like people with Kluver-Bucy syndrome, this classic syndrome where people, the animals would like lick inanimate objects or try and have sex with inanimate objects. What you've really disrupted is the relationship between internal state and external events. And it becomes rather random. So the amygdala is not a fear center. The amygdala is a tether that tends to bias us towards behaving or not, depending on what's being tethered. So for instance, if I suddenly see a dark object walk past my window at night, and then I'll pause. If it comes closer and my stress level goes up, then I now am in this high state of vigilance, aka fear. Now, if that thing disappears, it walks away, I'll start to feel relaxed, okay? The amygdala will then essentially, it's not responsible for the relaxation, it's responsible for me changing my behavior in response to that relaxation. So the amygdala is kind of like a security guard that can't actually do anything. You know those security guards that can't actually do anything, that can just use their radio? You sometimes see those at malls, and something happens and they can only call for the police. They can't actually do anything. So that's one way to conceptualize the amygdala. And this interoception, exteroceptive relationship doesn't have a name in neuroscience. Maybe it has one in psychology, but it's a fascinating aspect to our experience because it's very dynamic. And I should just mention, in sleep, what's incredible is that the tether is completely dismantled. Our experience is all internal. We are 100% interoceptive. But in dreaming, we're, thinking about things and things are happening more or less at random. Space and time are untethered. This barbell becomes like two spheres that are linked by a piece of dental floss floating around in space and swirling. So space and time becomes very fluid. When we are in fear states or alert or focus states, bam, the tether becomes locked. And now our internal state is very much driven by whether or not the email in front of us says what we want it to, or whether or not a comment made to us on Twitter, all of a sudden we are locked, we are tethered to that comment, and we're like, wait, how could you possibly say that? And I consider that a direct affront, or, oh, I love that, that makes me feel so wonderful. So your space and time is governed by the rigidity of this tether. Or we could also say our space-time relationship is also governed by how loose and fluid this tether is. So in relaxed states, we tend to be very open to new contingencies, mostly because our internal state isn't locked to events around us. When we are in very high stress or very excited, positively excited states, our entire interoceptive world becomes linked to the external world. And the amygdala is crucial as a linker between the external and the internal. That's the simplest way I can think of to describe it.
Yeah, and if we think about what brain alterations you see in those who are psychopaths, I think that it's really interesting because psychopaths have a very low startle response. It's hard to startle psychopaths. And I think that's related to a lot of what you're saying. It's not necessarily just threats that they don't get startled by, but they don't tend to, get terribly moved by a beautiful flower either.
Right. They tend to, I have a couple of friends who come from a background in military special operations, and have the great privilege of working with some people in those communities for sake of working on human performance things and also some of the rehabilitative things. And it's an amazing community because they are extremely good at what they do. They are selected through the most stringent protocols you could ever imagine, much more stringent than even the stuff we see about, carrying logs in cold water, all that, but much more. And yet their main function is to be able to act effectively on their environment. And yet they are unique and distinct from sort of sociopathy because they also have an incredible ability to integrate the goals and desires of other people in a way that's beneficial. It's a really incredible thing. I think also very charismatic people, politicians, when people say, in the presence of whoever this person was, you just feel good. Some people are just very good at dynamically interacting with people in a way that makes them feel brought in and seen. That there's a story, actually, a friend told me that he met Oprah, and he said, I've never met Oprah, but he said that the way that she moved through the room was stunning because she's always getting approached, right? Everyone wants to talk to her and, et cetera. And she would just acknowledge people one by one in a way that made people feel truly seen. And I said, what was it? Was it like her gaze? And he said, I have no idea. But when she arrived at him and just said, hi, so nice to meet you, moved on, he felt like, he said it wasn't just who she was, it was the way that she was able to engage at almost kind of a trivial level, felt like the glass had been poured completely full for the first time. And I thought, wow. And this is a person who's not easily shifted around by that kind of thing. He doesn't fan out. He's not really obsessed with celebrity or anything like that. So I think some people are just, naturally or through training or whatever it is, are just very good at engaging other humans in a way that makes them feel good. And I think sociopaths use that to the worst possible ends. And people and other people like, Oprah, who seems like a nice person. I've never met her, but certainly.
You're not calling Oprah a sociopath.
I am absolutely not calling Oprah a sociopath. I think quite the opposite. I think she has my sense is that she has a deep empathy. And I think that when people feel truly seen by somebody, it's the opposite of manipulation, right? And unfortunately, we hear stories about sociopaths manipulating people, but and of course they're out there. I'm sure my lab has never focused on studying them. I kind of don't want to because I don't really want them coming to my lab. That's the last thing I want is a bunch of sociopaths coming to my lab. Mm-hmm. But the link between the internal and the external and goal-directed behavior, I think is, again, it's one of these tractable areas of neuroscience and psychology that I think we're just right now at the infancy of understanding. And what's missing is a language, right? We have language for so many other things. We don't have a language to describe what I just talked about. It doesn't exist.
Great point. I'd like to take a moment to share about one of our sponsors, Skillshare. When was the last time you picked up a new skill or decided to build up an existing one? I signed up for Find Your Style on Skillshare the other day, and I'm already learning so many strategies for exercising my creativity. Skillshare is an online learning community where you can accomplish real growth with so many different classes to explore. Whether you're interested in creative writing and film or entrepreneurship and web development, Skillshare has classes for folks of any experience level. You can work on hands-on projects and experience real improvement. Skillshare is also incredibly affordable, especially when compared to pricey in-person classes and workshops. Explore your creativity at Skillshare.com/psych and get a 1-month free trial of premium membership. That's 1 month of premium membership at Skillshare.com/psych. I'd like to take a moment to talk about our sponsor, BetterHelp. Is there something interfering with your happiness or preventing you from achieving your goals? For quite a lot of us right now during this coronavirus pandemic, we are struggling with our most fundamental basic needs, such as our needs for security, connection, and opportunities to master our work. I think all of us could use some therapy right now. I know I sure could, which is why I've really been enjoying working with a professional therapist at BetterHelp so I can realize the best version of myself even under the current circumstances. BetterHelp will assess your needs and match you with your own licensed professional therapist, and you can start communicating with your therapist in just under 48 hours. Note that it's not a crisis line and it's not self-help. It is professional counseling done securely online. There's a broad range of expertise available, which may not be locally available in many areas. In fact, the service is available for clients worldwide. What I really like about BetterHelp is that you can log into your account anytime and send a message to your counselor. You'll get timely and thoughtful responses, plus you can schedule weekly video or phone sessions so you won't ever have to sit in an uncomfortable waiting room as you often have to do with traditional therapy. BetterHelp is really committed to facilitating great therapeutic matches, so they make it easy and free to change counselors if needed. It's more affordable than traditional offline counseling, and financial aid is available. BetterHelp wants you to start living a happier life today. Visit their website and read their testimonials that are posted daily. Here's a recent one. Camilla helped me turn my life around. Everything has been so positive for me since our first session. Deep gratitude. I'm pleased to announce a special offer for listeners of the Psychology Podcast. You can get 10% off your first month of professional counseling by going to betterhelp.com/psychpodcast. That's BetterHelp/psychpodcast. Join the over 1 million people who have taken charge of their mental health with the help of an experienced professional. Okay, now back to the show. I'd like to move on to another topic, and that's motivation. What can people do if they feel very unmotivated in their lives? Like, I just feel like that's just a common thing right now with COVID. People are like, just not languishing. People just don't feel like they're necessarily flourishing, during this time, right? So what can people do to kind of get that motivation back?
Mm-hmm. Well, from a very core physiological perspective, motivation is the combination of two neurochemicals, what we call neuromodulators. And those two are epinephrine, it goes by another name called adrenaline. We need energy. We need to move. And we often think that energy comes from food, and it doesn't. Energy comes from neurotransmission and from particular neuromodulators. We need to eat, of course, to sustain ourselves, but goal-directed behavior requires a fuel, and that fuel is epinephrine. And there are ways to increase epinephrine. We'll talk about it in a moment. The other is dopamine. The neuromodulator dopamine does many things. It's involved in reward and feel good, but its main job is craving and motivation. I have a colleague at Stanford, Anna Lembke, spelled Lembke, who's a psychiatrist. She actually has an amazing book coming out in August called Dopamine Nation. Is all about dopamine and addiction. I think you guys would really enjoy it.
I want to talk to her. Yeah.
I'll put you guys in touch. She's an incredible person and clinician. And she talks about dopamine as the molecule of craving. There's also another book called The Molecule of More, which is very good about this. Dopamine isn't about reward, it's about craving and motivation. And dopamine at the same time is something that we get more of when we reach milestones. So epinephrine and dopamine are close cousins in motivation. There is a way to increase epinephrine, just pure physiology. And a lot of people are already doing this, and my lab has looked at this a bit, but there are ways to breathe that will increase epinephrine. And there's another way to do it, which essentially costs nothing as well, which is you can throw yourself into cold water or get into a cold shower. Now, there are a lot of reasons to do cold exposure as long as it's done safely. But one of the things that isn't often understood is that when you get into a cold shower and you decide to deliberately stay there for 1 to 3 minutes or maybe even longer, you are releasing adrenaline from your adrenals, and you're releasing the same molecule from your brain, which is epinephrine. It's called epinephrine in the brain. It's adrenaline from the adrenals in the body. Getting into an ice bath will do the same thing. That will increase your energy level. It is a mild form of stress, but it is energy level. Exercise will do it too, but a real quick way to do it is to get into a cold shower or an ice bath. Not everyone wants to do that. So with respiration, you can do this. My lab has studied this protocol. It involves taking 25 deep inhales and exhales So it looks something like this. So in through the nose, out through the mouth, 25 of those, and you will be alert. You will actually feel a little agitated. And for people that have panic attacks or prone to anxiety, you might not like it. However, if you finish 25 or 30 of those breaths and you exhale all your air and hold your breath for about 15 to 30 seconds and then repeat and do that 2 or 3 times. So 25, 30 breaths in through the nose, out through the mouth, in through the nose, out through the mouth, then exhale and hold, repeat, exhale and hold. What you'll find is that during the exhale hold period, you can achieve a state of calm with very high levels of alertness.
Wow.
This simple trick, I don't like calling it a hack because this is actually what the biology was designed to do. A hack kind of implies you're cheating the system. And I don't like the word hack because it always sounds like something's getting carved up. And, so I hate the phrase biohacking. I loathe it. What we're talking about here is actionable biology or applied biology. So you're increasing epinephrine. Now, what you do with that energy is up to you. But many people actually find that just by doing this pattern of breathing, they suddenly feel like they could or want to exercise, or they could or want to work. They could or want to get up out of their chair. So that's one thing that can be beneficial. The cold shower thing, and Wim Hof is famous for, the Iceman and for doing this breathing that's very similar to the type of breathing I described. It's a way of generating adrenaline in the body at low levels, but that allow people to get into action. Now, the dopamine component involves reaching some sort of milestone or craving something. Dopamine is best served not just by reaching a goal, but by craving a goal. And Dr. Lemke, in fairness, she's a friend and a colleague, so I call her Anna. But Dr. Lemke, because she is a board-certified psychiatrist, has talked about this as, let's say you eat a piece of chocolate. We think that the dopamine release that you get from that is actually about the satisfaction from the chocolate. But the next time you eat something delicious, pay careful attention. The good feeling that you're feeling is actually the craving for more. It is not an absolute joy in what you're doing. And this is fascinating, and it's at the heart of addiction, right? The cocaine user or even the pot user, and I realize nowadays a lot more people, use pot legal and stuff, so it's complicated. But that craving for something or for sex or for whatever it is, that excitement is craving. It's not reward. And that's because dopamine and pleasure and pain have a very unique combo. I'll leave it to Dr. Lemke to complete that discussion because she can describe it so much more eloquently and accurately than I can. But the way to get dopamine is once you are in action, set a milestone. Okay, today I'm just going to go out for a walk, or today I'm just going to send 10 emails related to some business-related goal, or whatever it happens to be. That can help dramatically. But without epinephrine, without the bias toward action, it is very hard to get out of complacent, inactive states. And remember, stress and excitement at a neurochemical level are just epinephrine released in the brain. But dopamine is the reset. It's kind of the re-up of epinephrine that allows you to repeat that over and over and over. And from a purely biochemical perspective, most people don't realize this, but epinephrine, adrenaline, is made from dopamine. The biochemistry of dopamine and the biochemistry of epinephrine are such that they are linked. You cannot have epinephrine without dopamine synthesis. So if someone has a real clinical depression and they're low in dopamine, well, then talk to a psychiatrist. There are drugs out there like buprenorphine, Wellbutrin, and things like that, that they work by increasing dopamine and epinephrine. Very distinct from other antidepressants that like Prozac, which increase serotonin. Serotonin is the molecule that basically makes us feel pretty good with what we've got in the present. It does not tend to drive motivation. It tends to come from eating, from having had a satiating experience or meal. It's not involved in craving as much. And of course, I'm talking about these chemicals in very coarse terms. They have subtlety to them as well.
Of course. Yeah. My colleague, Colin DeYoung, has a really wonderful paper linking dopamine to the personality system. And just to tie this to psychology and he calls it the neuromodulator of exploration. That's the word he uses, exploration.
Mm-hmm.
Because extroverts score very, very high. They have a lot of dopamine production, particularly in the striatum and lower subcortical structures, that motivate them to explore the social world. It's like all about, oh, I want to like never enough. It's never enough for them. Like they always need someone new, or else they get bored.
Right.
Yeah.
Yeah. And, this lies at the kind of deepest levels of our evolutionary biology. The anticipation of sex which of course underlies reproduction, which underlies the progression of our species. Of course, there are other reasons people have sex, but the dopamine is produced in pursuit of and during sex. But just to be concrete about it, after orgasm, dopamine levels plummet, and a hormone called prolactin is increased. Prolactin sets a quiescence. It's actually also what's released in new and expecting parents that calms them down and makes them very focused on the needs of another, right? Mm-hmm. You can't be running around like crazy, certainly not looking for new mates shortly after a child is delivered into a relationship or even a single parent. And when prolactin goes up, it tends to make us more quiescent, not want to seek novelty. It makes us content with what we have and put us into caregiving roles in both men and women, and every variation thereof. And in animals and in humans, it tends to throw down body weight in theory, to make us able to tolerate long nights of no sleep, to raise young. So dopamine is involved in the pursuit of food, the pursuit of sex, the pursuit of money, but the moment that we reach those goals, there's a huge plummet in dopamine, and then it resets over time it resets for the pursuit of more. And I think the book, The Molecule of More, describes this really, really nicely. I think it's Daniel Lieberman. It's definitely Lieberman. I think I have the first name correct. He's a psychiatrist at GW at George Washington. Or Georgetown. Forgive me, I don't know his affiliation. That's a great book about this too. But I think that we can take advantage of the biology of epinephrine and realize that when we have increased levels of epinephrine, we need to move. And sometimes that can be keys on a keyboard and focus. Sometimes that can be actual physical movement around, exercise, et cetera. One of the most challenging things is to have high levels of epinephrine in our system and to be sitting still. That's called stress. And 2020 was a forced situation of limited movement from our usual routines and a lot of incoming information that was very triggering to a lot of people. And I realize we're still somewhat in this thing now. It's not like New Year's hit and we're out of it. But whether or not it's for work purposes or fear of COVID, et cetera, it's clear that bodily movement is a very, very good thing. And that the more we physically move, the more that these circuits in the brain and body that underlie motivation get carried out. Because the reason we have a nervous system, I wasn't consulted the design phase, but logically speaking, evolutionarily speaking, the reason we have a nervous system is to move. The only way we can affect anything besides ourselves, other people, other events, et cetera, there are only two ways. One is movement and the other is sweating, right? Mm-hmm. Our sweat can affect people, not very in major ways in most cases, but movement is how we speak. Movement is how we eat. Movement is how we reproduce. Movement is everything. And so epinephrine is like an engine beneath movement. Dopamine is like a rudder that steers us toward particular things as we move.
That makes a lot of sense. Like I mentioned Colin DeYoung, but I just want to bring up another part of his theory, and that's that there's this nerdy dopamine pathway that people are starting to understand, where you can really get energized at the potential reward value of information. So that's for all us nerds out there. There are dopamine projections to the dorsolateral prefrontal cortex. Yeah. It's not all just sex, drugs, and rock and roll with dopamine. So that's another kind of misconception. Absolutely. I wanted to kind of I've been trying to dispel that misconception.
Oh, I totally agree. Dr. Lemke, Anna would talk about, and does talk about internet addiction. She was actually featured in The Social Dilemma.
Cool.
She doesn't have a big presence on social media as a consequence, although I think she has a somewhat of a presence there. But she, I talked about this with her. She accused me of being a work addict, and she's probably right. I love learning. It feels good. It feels like a drug to me. It feels like a healthy drug. And so I love information. So I guess I have the nerdy dopamine type. And I love both. YouTube. I think YouTube's amazing. I think YouTube is an endless library of amazing stuff. There's also a lot of garbage, but so I'm glad you pointed that out, because we can forage with our minds just as much as we can forage with our bodies, except now foraging with our minds is made much more accessible than foraging. It's actually come to replace foraging with our bodies. And so we forage with our minds. And I think I love that concept. Who's the gentleman that you said?
Colin DeYoung. I'll send you the paper. Colin DeYoung.
Great.
Yeah.
Fantastic.
He's a personality neuroscientist. He actually is leading the field of personality neuroscience. And I'd love to see what sort of connections can be made between the kind of work you're doing, the kind of work he's doing, and that I'm doing with him and stuff. But
great. That sounds amazing. When I was at Berkeley, Bob Levinson was setting up his physiology lab downstairs. And I remember thinking, wow, I didn't know that psychologists did physiology, because back then it was pretty rare. Now there are all these wonderful mergers of fields. So it's Dacher Keltner and those guys were doing that. Yeah, so great stuff.
Really great stuff. Just want to end this interview by getting a little bit of an understanding of your chronotype management. How do you manage your unique chronotype? Do you have any suggestion? I want to know your daily routine, but can you also kind of just tell us about the science about when you should sort of be doing certain things during the day in general for optimal brain development?
Sure. Okay, so there are 4 things that act as very powerful levers on when you will be awake and when you will want to be asleep, when you will be able to do your best work, when you'll be able to do your creative work. And those are your exposure to light, in particular sunlight. So light is one and is the most dominant one. The second is temperature. It's vitally important, environmental temperature and your temperature. Movement, aka exercise, but activity of various kinds. And then when you eat, and to some extent how much you eat. That's easily handled. If you eat a large volume of any substance, it will bring more food to your gut, so it will make you sleepier. If you eat a moderate to just quote unquote healthy level of any substance, it will tend to not overwhelm your system and you'll be alert. But there are certain things that you can eat to be more alert and certain things you can eat to be sleepier. So I just want to be clear. So let's think about light first, and then I'll reveal my schedule according to chronotype. So regardless of chronotype, if you're a night owl or a morning person, et cetera, you want to get bright light, sunlight in your eyes within the first hour of waking. If you wake up before the sun comes out, you want to turn on artificial lights as much as possible if your goal is to be awake. So put simply, if your goal is to be alert and to wake up, turn on a lot of lights, especially overhead lights, because of the position of these neurons in the eye that reset our circadian clocks. Overhead light triggers alertness in the brain more so than does light right in front of you or light down low. So early in the day, try and get outside, even if it's overcast. There's a lot of photons coming through. About 10,000 times more photons coming through a densely clouded sky than a really bright internal artificial light. So get bright light, and through a window is 50 times less effective. So I've talked to now thousands of people who tell me just making this one simple change can really help, because it triggers a circuitry in the brain and body that activates alertness and focus throughout the day through the cortisol system, healthy cortisol levels, et cetera. And it also triggers a timer so that the hormone melatonin is secreted about 12 to 16 hours later, which makes you fall asleep. Okay, nice. So the simple rule is get a lot of bright light early in the day and throughout the day. So for those of you wearing blue blockers throughout the day, it's a huge mistake. Huge mistake. Is it like, don't do it.
I know someone who
It's
does
just-
that. I know someone who does that.
It's just limiting your alertness. I think people like the way they look or how they feel when they wear them, but blue blockers in the evening can be very good because you want to limit or start to taper the amount of light that you get in the evening hours, and you want to avoid bright light exposure between 10 p.m. and 4 a.m. unless your job is to be awake at those times. And the reason is it can suppress melatonin, which is the sleepiness hormone, and it can suppress dopamine. There are 2 studies showing that. And dopamine is important. It can suppress learning. It can cause depression at low levels. It can exacerbate depression for other reasons. That's caused by other reasons. So a lot of light during the day and morning, especially in the morning. Try and get it from sunlight. Try and not get it through a window. It's okay to wear contact lenses or eyeglasses when getting this exposure. But if you can safely do it without wearing sunglasses, better to do it without wearing sunglasses. But please don't drive off a cliff or injure your eyes or something. Never look at any light that's so bright it's painful to look at. Okay, so I'll reveal my schedule. I wake up, first thing I do, so I try and get outside, get 5 to 10 minutes outside, walk my dog, maybe even to read. It's going to be indirect. You don't have to stare directly at the sun. If it's still dark out, I'll turn on a bunch of lights in my home if the goal is to wake up. Then as you move into the day, most people, because temperature starts to increase after you wake up, most people are going to be most alert and feel most able to do various kinds of mental and physical work somewhere between 3 hours. So I would say at about 3 hours after waking and 11 hours after waking. There are these 2 little peaks in our circadian timing mechanisms. You have to figure out when you do your most focused work, but for most people, they can do their highly focused work about 90 minutes to 2 hours after waking. So this is mid-morning for most people. And that's going to be time where linear work, meaning the kinds of work that requires a lot of focus, and you more or less know what you need to do, but you know the strategy, but you need to implement the strategy, or you need to figure out the strategy. So very focused kind of analytic work. And that's a terrible time to do email or be involved in meetings because it's going to suck away your ability to do really what Cal Newport would call deep work, right? Fasting and low carbohydrate intake favor alertness because it leads to a state of increased adrenaline. So I typically don't eat until about 11 or noon. I sometimes have some almonds or something like that, or fat. Sometimes if I'm very hungry, I'll have some eggs or something like that. But I generally fast until about noon. And then at noon, I eat a meal, which is generally some sort of meat or fish or chicken or something, and a salad. I like cold food, and I don't eat much carbohydrate. Now, there are exceptions to this. Occasionally, if I did a hard workout early in the morning, which I rarely do, I usually work out later these days, then I might eat some more carbohydrates. But typically, if you eat starches, like pastas or rice, et cetera, we always hear that gives us energy. No. Your energy comes from your glycogen stores, which are in your liver and your muscles, and your adrenaline in your brain. You have to restock that stuff. But if you want to be alert, fasting, water, caffeine, make sure you're getting enough electrolytes. So salt is important. If you're fasting or not and drinking a lot of water, you can deplete electrolytes. A lot of people get kind of dizzy because they're not eating enough salt. Unless you have hypertension, it's generally safe to consume some salt. And so the daytime is when you want to be alert and working. And then after lunch, everybody experiences a little bit of a dip, but the lower carbohydrate intake during the day can prevent some of that dip. In the afternoon, I continue with the same, but I do a second work block in the afternoon, which I always do what's called a non-sleep deep rest protocol. Once per day, I take 20 or 30 minutes, sometimes 10 minutes, and I do either yoga nidra, which is where you just lie down and listen to a script. I've put one out there, totally cost-free, where you can just put on YouTube, NSDR. It was hosted by a company called Made For, but it's totally free of cost. That takes you through a deep relaxation. This non-sleep deep rest has been shown to bring the brain and body into states that favor neuroplasticity. That was published several times, including last year. Replenish dopamine in the striatum. That was published by a group in Scandinavia. Or I'll do the Reverie app. I'll do the hypnosis for kind of deep relaxation. I come out of that. I usually drink a little bit of caffeine. I do drink coffee and caffeine. And then I'll do some sort of work for about 90 minutes or so that's more kind of creative work, like writing or something where the strategy isn't quite clear. It's a little bit more challenging. And I do this because in the afternoon or when we're sleepy, we a little bit more relaxed, I should say, not sleepy, we are able to create new contingencies. Creativity is taking existing things and organizing them in new ways in space and time. And that kind of space-time rearrangement is favored by states where we are deeply relaxed, not necessarily sleepy. So I try and do a 90-minute block of focused work early in the day and a 90-minute block in the afternoon. And during that time, I turn on a program called Freedom, a free program on my computer that locks me out of the internet. And I turn off my phone and I lock it in a safe because I'm not very disciplined with the phone otherwise. And then evening is when your temperature starts to drop. Some people exercise in the evening, which is fine. If you are going to do, I should say, if you're going to do cold water exposure, you want to do that early in the day because it's going to favor alertness. Ice baths, cold showers. If you're going to do things like sauna, hot baths and things, those should be done in the evening for preparation for sleep. There are exceptions to this. Some people like to do it early in the day, but temperature is a powerful determinant of these internal states. And then my evening meals generally consist of more carbohydrate, pasta, vegetables. I might eat some fish or eggs or something like that, but generally they're more carbohydrate laden, which makes sleep fantastic. I'll tell you, carbohydrates really favor sleep. We all heard, never eat after 6 p.m. Carbohydrates are bad for you. They lay down body fat if you eat them late in the day. Nothing could be further from the truth. There's zero evidence for it. They facilitate the release of things like serotonin, which lend themselves well to sleep. So I cut out the caffeine in the late afternoon and evening. I end up eating some starches after I do my exercise, and that helps you taper to. And I limit my light exposure, especially overhead light exposure. You want to, if you're going to have lights on in the evening, set them low. That would be the time to wear blue blockers if you want. But I should say that any light, if it's bright enough, will trigger activation of the alertness system, even if you're wearing blue blockers. So dim screens and kind of fade things out. And then I do use supplements to support sleep. I'm not a fan of melatonin because it has effects on other hormones in the body. But for some people, and again, I'm not a physician, so I'm not telling people what to do. Always check with your doctor. Things like magnesium threonate, spelled Threonate, or biglycinate, can help create a state of kind of sleepiness. They trigger activation of the GABA circuitry, which kind of turns off thinking, etc. Theanine, Theanine, and something called apigenin, 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 which comes from chamomile. Many people benefit from taking those to allow them to relax. But of course, check with your doctor. I would say the two single most important protocols that I've adopted over the years and for which there's great scientific data are morning bright light exposure to the eyes. Again, never so bright that you're going to damage your eyes. You'll know because you'll blink if it's really bright. Definitely blink if you need to. And these non-sleep deep rest are doing a 20 or 30 minute deep relaxation protocol once per day because they help you get better at falling asleep, right? That's what these non-sleep deep rest protocols do. They help you get better at relaxing. Humans have no trouble activating their stress circuitry, but they somehow, nature, evolution made it such that we have to learn how to calm ourselves. So that's what I do, and I do a bunch of other things too, but those are that's kind of the general framework. And I should say that if you are a night owl, you should still try and do the same things. But instead of trying to avoid light from 10 p.m. to 4 a.m., maybe you avoid light from like 2 a.m. to 8 a.m. I don't know. Everyone's schedule differs. If you're an early morning person, my advice would be do not push past your desired bedtime too far, because what happens is many people wake up at 3:30 or 4 in the morning to use the bathroom. That's totally normal. Go back to sleep. Waking up once during the middle of the night to go to the bathroom, no big deal. You don't want to drink too many fluids late at night for that reason. But if you're somebody who's waking up at 3 a.m. and you cannot fall back asleep, chances are you are supposed to go to bed at 8:30 or 9 p.m. And unless there's an underlying anxiety, what's happened is your melatonin has run out and you're awake. The problem is it's very easy for people to push their bedtime out. It's much harder for people to go to bed early. Yeah. We've experienced this when you travel. You can always stay at the party, but it's very hard to say, okay, snap your fingers and fall asleep. So if you're somebody who wakes up at 3 or 4 a.m. and you're having a hard time falling back asleep, try and go to bed earlier. and then wake up at 3 or 4 a.m. and you're one of those lucky people that can get much more done in life than the rest of us.
Nice. I like it.
Yeah, so that's the suggestion. And then most people will have a kind of typical chronotype. You'll want to wake up around 6:30 or 7:30 a.m., depending on age and lifestyle factors. And you want to go to bed around 10:30, 11, sometimes 12 p.m. That's the typical pattern. So those are the main things. And as you can see, they relate to light, temperature, food, and exercise. And if you're going to exercise late in the day, well, have a protocol to bring yourself down afterwards and avoid too much caffeine. If you're going to exercise very early in the day, understand that you're shifting your clock a bit. Anytime you do something regularly that involves a lot of activity, you're creating a system in your body of anticipation of that activity. So if you want to wake up earlier, wake up a few days, set your alarm, force yourself to do it, and exercise at 5 a.m. Pretty soon you'll start waking up at 5 a.m. That's just the way these circuits work.
I love it. If you like the kind of guests and themes we have on the Psychology Podcast, you're going to love The Jordan Harbinger Show. In each episode of Jordan's show, which Apple named one of its best of 2018, Jordan dives into the minds of fascinating people, from scientists and authors to athletes to mobsters, spies, and hostage negotiators. I recommend our listeners check out Jordan's conversations with physicist Michio Kaku on The Quest for a Theory of Everything and therapist Linda Carroll on unlocking lasting love skills. Jordan's always focused on pulling useful practical insights out of his fascinating guests. And we're not talking about pop psychology or wish-washy self-help stuff here. The episodes are often loaded with bits of wisdom that you can use to legitimately change your mind and improve your life right away. It's definitely worth checking out. There are very few other podcasts to listen to casually or seriously to expand your worldview. He's also got a relatable weekly segment called Feedback Friday, where Jordan covers advice on everything from escaping a cult or psycho-family situations to relationships and networking to asking for a raise. Jordan Harbinger is smart, funny, and easy to listen to. You'll be hard-pressed to find an episode without excellent conversation, a few laughs, and actionable advice that can directly improve your life. You just can't go wrong with adding the Jordan Harbinger Show to your rotation. I really enjoy the show and think you will as well. There's just so much there. Check out jordanharbinger.com/start for some episode recommendations, or search for The Jordan Harbinger Show. That's HARB as in boy, IN as in Nancy, GER on Apple Podcasts, Spotify, or wherever you listen to podcasts. There are so many different topics we could have nerded out today, and maybe we'll table some for when I'm on your podcast and we can continue
Great.
or even just hanging out here on the beach. We can continue our conversations. But one big topic is flow. Something that a topic we're both super interested in. I know we both have a mutual friend, Stephen Kotler. How does this no-go sweet spot that you talk about relate to the flow state? And then maybe we can end there.
Sure. So, flow still remains a little bit unclear as a neurobiological state. But I talked to Stephen about this, and what I really appreciate about Stephen is he's intensely curious about all the things that it could be, not just saying this is what it is. And I think that's something that there are many things that make Stephen a unique and special character and serious thinker. But that's one of them. But so flow to me is when our interoception and our exteroception, that barbell model that I described earlier, kind of glass barbell, when that suits our goals almost perfectly. So if I could even say, like, during this podcast, right, I was very focused on what's going on here, and you and I we're tethered in, and we're in flow, right? I mean, I wasn't thinking about the fires outside or my dog over to my left, or my attention might have diverted here and there for a moment, but we were in this space-time thing that worked well, I like to think, for the conversation we're having.
For sure. That
to me is flow. Now, what's challenging is understanding how we transition in and out of flow. And I think that's where at some point it can be operationally defined. I could not describe the set of neurobiological events that allow that to happen. But what we know is that the brain and nervous system, which of course links the brain and body to brain, it somehow figures out very quickly what are the contingencies? What are the relevant things that need to be handled here? What are we going to do? And it starts peeling away all the irrelevant stuff. And so that my internal state is going to be matched to what's going on and back and forth. And I think that it certainly involves activation of these frontal circuits that harness our focus and our decision making. And the way I like to think about flow is speaks to a little bit of how I like to think about the nervous system generally, which is that it's like a bookshelf, but it's almost like a bookshelf in a Harry Potter novel or something. It's very dynamic. So we sit down and I say, okay, here's Scott. We've met once before in person. I read your tweet, so I have a context. It's like a bunch of books on the shelf. And then as you start to engage in the conversation, things pop up. So it's Dr. Lemke and Huberman and like all these things, and we start creating a context. So this bookshelf is very dynamic, and so what's brought to the front of your attention starts becoming more and more narrowly constrained, right? Mm-hmm. But as we end the podcast and we get up and we go about something else, the brain doesn't just shut down our view of that bookshelf. It's still chattering in the background. And so a lot of what I think the research around flow, if I may, should be centered on is how to access those states more quickly and more deeply. Because I think that we experience this whenever we pick up our phone and we start scrolling Instagram or Twitter. What they've done so beautifully, and almost sometimes to our detriment, but beautifully with social media, is that there's a ton of libraries of different types of information packed into a very narrow context. And so we're basically library flipping. If I look at your tweet and then I look at another tweet, they have no relevance to one another. So it's almost like being in one section of the library looking at anthropology, and then all of a sudden I'm in geography, and then all of a sudden I'm in neuroscience, and all of a sudden I'm in the murder mysteries. And the brain sort of will try and lock to each one of those. And so it's anti-flow in one sense, but it's the flow is all within the context of the application. When Kotler talks about flow, like on his mountain bike or while skiing, or it's so tangible because in physical pursuits, we don't have the option to, mountain bike and ski at the same time. I mean, you could come up with some silly hybrid of that, but we don't have the option to cycle and swim at the same time. But with our mind, we have the option to leap back and forth all the time. So to me, flow is going to be best understood first in these very well-defined physical pursuits. But throughout the day, I'm always thinking about what is my tether locking? What is it? And this is why I both loathe and love this device, the phone, because I find that it can allow for billions of contexts to enter my brain. Yeah. But that's part of the problem, right? And so drilling down into a question like we had this unfortunate incident we were talking about before we started recording, that there was an arson recently in the area. They caught the guy, fortunately. We were asking, what leads somebody to want to do this? Went down the rabbit hole of arson for a little bit. That's actually an exploration of a single topic, which from a perspective of brain function is very normal and very healthy to think about a topic in sequence and go more and more deeply into it. It's actually kind of feels good. Yeah. What is diabolically diabolical and is actually bad for us is when our brain is constantly switching between contexts and a feed. And that's what I think is the problem. If I had my way, I'd be able to filter my Twitter feed by psychology and neuroscience, and then I'd switch to like the other things I really enjoy. Yeah. Like I'm a total animal nerd, So I don't know if that's a very good answer, but I think that flow deserves more work, and it has to do something with our brain's ability to set context very narrowly. And we know that focus and narrow context setting is absolutely the place in which we experience deeper satisfaction, the place we experience great learning and great growth, and where we access neuroplasticity, the brain's ability to change. I've never been changed by simply scrolling through an Instagram feed. I've been changed by reading a chapter in a book. I've changed the way that I think in general, or very specifically, about stories that I've read or interactions that I've had. And it's not to say that social media is evil. I teach neuroscience on social media. You have access to many, many more people, I would say, right, than you would be able to access if you were just locked away in some university office. But I think we should think about how many contexts our brain is locking to each day. And I think we should potentially embrace a concept, not just of flow, but of anti-flow. And anti-flow is what we're doing a lot of the time. And anti-flow is the enemy of neuroplasticity, and anti-flow is the enemy of the ability to achieve flow. I do think that flow is a skill, and I think Kotler would probably agree, although I don't want to put words in his mouth. I'd love to know what you think about this, because I'm just kind of riffing at this point.
Yeah, I think this is a to be continued conversation for us, because I'm eternally fascinated or perpetually fascinated by this topic and really interested in my work on the coupling of the executive attention network and the default mode network in just such a way that you get the optimal state of flow, where the attentional executive attention is lowered just enough that you're directly accessing the rich internal fantasies and associations. And so it gives you that feeling of like you're just jamming, so that's the topic of creative flow. I think there's different types of flow. That we're having social flow right now, which I think might be activating different brain networks than if I'm doing jazz improvisation or if I'm just doing creative writing or writing a poem. So I think we need to talk about the domain specificity of flow, in addition to how we, Kotler tends to talk about this like general sort of like let's have one theory to explain everything, and it's like that it's not possible. Does that make sense?
Yeah, absolutely. And I think that words like just as a reflection, I'm in such deep admiration of the sleep scientists. That have defined different stages of sleep: REM sleep, slow wave sleep, stage 1, stage 2, stage 3, stage 4, ultradian cycles. We sleep in repeating 90-minute cycles, all this kind of stuff, right? Early night dreaming is more about recovery of the body and motor learning. Later night dreaming is REM dominant, more about emotional uncoupling from prior experiences. It's kind of a therapy of sorts. We have basically zero taxonomy to describe waking states. And we have basically zero understanding of the neurobiology underlying those states. Whereas with sleep, we understand a lot thanks to the great efforts of that community. So I think the next 10 years of neuroscience and psychology, we are tasked with figuring out what is a really good taxonomy of states. And flow is what I would put under the category of highly desirable states. It sounds wonderful. Everybody wants it. It's like the thing you want. The reason my lab has focused on states that are far more mundane, like stress or calm or alertness or focus. We are interested in creativity, et cetera, is because I'm a big believer that we can build up our understanding to these more complex and highly desirable states through a basic understanding of the ingredients that go into feeling sleepy or alert. And it also probably reflects the fact that I love to think about high-level concepts. But at the end of the day, the question, that every PhD advisor asks their highly ambitious student or postdoc is like, okay, what's the experiment? I think every academic has had the experience of having this brilliant person come to them, highly enthusiastic, and the student says, I want to study blank, blank, blank. And you say, okay, great, design an experiment. And so I think with flow, we need to start designing experiments. And I'd love to be involved in that effort if ever there were the opportunity. And I'm sure there are experiments out there, but right now, I think is the time to start thinking about what are these states of waking. Like what state are we in right now, Scott? I don't know. I feel alert, focused, but like what is that? Does it have a name? Does it even need a name? Clearly, as you said, it's different than the kind of flow I would experience snowboarding or downhill skiing or something. Right. So more language to describe the nuance, but in a tractable way, right? Language can either confuse or it can clarify. And what I like so much about the way that you place things is that I can, because of your background as a researcher and because of your background and current ground as an academic, you know that ultimately there's got to be an experiment with which we can measure this. And I think we need more of that. And so this is also a reflection on how much I appreciate your knowledge, because I think that in the social sphere of internet psychology, most or a lot of what's out there is just naming stuff that sounds cool and sounds clickbaity, but that's not the same as understanding something at all.
Definitely not. And I think both of us, we want to understand the mechanism behind these things. And there's different mechanisms at play with different states of flow. And, I'm just going to end here and say to be continued. Like I know I keep saying that, but I really appreciate you coming to my podcast. I really appreciate what you're doing in this world, Andrew, and the passion for science as well as the rigor to science that you bring. You bring both those things, and that's a wonderful combination. So thanks so much for being on my podcast today.
Oh, thanks so much for having me on. It's been a real pleasure, and I look forward to many more conversations. And it'd be fun to grab another workout on the beach. That was fun.
That'd be a lot of fun. And stay safe from the fire. The fire's behind you. Yeah.
Yeah, you might be able to hear some of the planes and helicopters. Hats off to the firefighters that are doing this incredible work. And hats on for now. They should keep their hats on. But definitely they deserve a nod. They do such hard and dangerous and important work. And it's only when we have a fire that you stop to think, wow, there are these people whose profession is to basically save our lives and our property. So, and the police who caught the guy. So yeah, I'll stay safe.
Stay safe so we can hang out again soon.
All right, will do. Thanks so much.
Thank you. Thanks for listening to this episode of the Psychology Podcast. If you'd like to react in some way to something you heard, I encourage you to join in the discussion at thepsychologypodcast.com. That's thepsychologypodcast.com. Also, if you'd prefer a completely ad-free experience, you can join us at patreon.com/psychpodcast. Thanks for being such a great supporter of the show, and tune in next time for more on the mind, brain, behavior, and creativity.